Welcome to Real GMAT Problems, episode 31. Doing real GMAT problems is one of the most effective ways to make test day better. So let's talk through a few examples together. The problems that we're going to go through are from the 11th edition of the official guide for GMAT review, and you're welcome to web search them if you would like to follow along visually. Just so you know, the 11th edition, the official guide, is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guides, there shouldn't be any overlap between the problems that we're going to talk through today. The official guide contains retired problems that have appeared on past GMAT exams, so these are going to be extremely similar to what you're going to see on your official GMAT. I'll give you a chance to work through the solution on your own if you'd like, and then I'll discuss my thoughts on each problem and what I recommend learning from each one. I'll also recommend pausing after I read through each problem and trying to solve it, or at the very least, visualizing how you would solve it. You may not be able to execute all the steps in your head if you're like driving, for example, but just do your best. If you are in a situation where you can physically write down what you would on test day, that's definitely ideal. Let's go. I'm going to start us with a warm-up problem like I have in the past few episodes, just because some of the questions we're going to talk about today are like a little tricky, and I think it's good to just have something that's a little bit more basic at the beginning. And it pays to be as good at the basics as you possibly can be. You can never be too good at the basics. So I'm going to help you, or at least try to help you, work on those basics and build a great foundation, since that's a lot of what getting a great score is about. It's not everything, but it is a huge component. So this is problem number 131. The problem says a factory has 500 workers, 15% of whom are women. If 50 additional workers are to be hired and all of the present workers remain, how many of the additional workers must be women in order to raise the percent of women employees to 20%? I'll read that again. A factory has 500 workers, 15% of whom are women. If 50 additional workers are to be hired and all of the present workers remain, how many of the additional workers must be women in order to raise the percent of women employees to 20%? Option A is 3. Option B is 10. Option C is 25. Option D is 30. And option E is 35. Again, I recommend pausing here and doing your best. It's a great problem here because if you've been following the series for any length of time, you've probably seen how often percent math shows up. By far, percent math is the thing that you're going to do the most of on the GMAT quant section. So these kinds of problems that work and test your basic approach to percent computation are extremely valuable. It's also a good warm-up problem because if you're solid with your percent computation approach, you're very likely to get it right. So let's strengthen those key foundations together before we look at a couple more complex questions. First of all, there are quite a few ways to solve this one. You can set up a proportion and use algebra. You can even guess and test with the answer choices. But I think you'll find that one of the fastest solutions involves just doing the percent math one step at a time. So it's kind of like a logical step-by-step approach rather than a set up a grand equation and solve that equation approach. Now, if you're getting great results by setting up equations here, awesome. Don't change what you're doing. But if you're interested in an alternative, I'll talk through one in a second. And just to be clear, there's no like quote unquote universal best way to do this problem. There's just the best way for you. And I'm going to help you figure out what that best way is. At the same time, if you're the type of person who just wants like a one recommendation per problem, I totally understand that. The whole process can be quite overwhelming without adding additional solutions. So I'll give you that as well. But let's explore this like algebraic reasoning, step-by-step kind of logical approach rather than the equation approach, since I don't think these kinds of approaches get a ton of airtime, and I think they're at least worth considering. It's going to sound almost like not an approach, if that makes sense. Like we're just going to compute the math in the problem one step at a time. We can start with the first pieces of information that we're given, which is there's 500 workers and 15% of them are women. I recommend doing your percent calculations as fractions. I've recommended that a bunch in the past. Obviously, there's many ways to visualize percent calculations, including decimals, but I've noticed that most people are really prone to mistakes when trying to do decimal computation without a calculator. And if you're just starting out, there's no calculator on the GMAT quant section. You'll have to do the math by hand or in your head. So the way I would set that computation up, 15% of 500, is just 15 over 100 times 500 over 1. If you're just getting started and you want a primer on how to do math with fractions, we've got a specific lesson on that linked below. We've also got a lesson on percents there for you. Suffice to say, if you are comfortable doing that calculation, you will get that 15% of 500 is 75. I'm not going to go through all the math here because I've done that in a lot of past episodes. And again, that Math Basics series is there for you if you want to upskill with that. But I'm just going to assume that you either know what I'm talking about with that calculation or you're capable of doing it or you've rehearsed it enough to at least follow along. But definitely let me know if you feel like going through the specific math is super valuable in a situation like this. I'm going to use my best judgment as someone who has your best interests at heart here to pick when to do the hardcore math together and when to kind of gloss over it. But myself and everyone on the team here is super open to feedback, so you can reach out to us anytime. We're at the GMAT Strategy on current social channels if you prefer DM, or you can email us contact@thegmatstrategy.com if you have any feedback and you want us to change anything here. So 15% of 500 is 75. And what that means is there's currently 75 women employed at the factory. Now, all I'm going to do is just go to the next percent calculation in the problem. We are going to add an additional 50 employees, to our 500. So we're going to have 550 total employees. And we want 20% of those 550 employees to be women. So let's figure out what 20% of 550 is. As I noted, I recommend doing that as a fraction. So that's going to be 20 over 100 times 550 over 1. If we perform the math correctly there, we should get that 20% of 550 is 110. That means we need 110 of our 550 employees to be women. So we already have 75. How many would we need to add to have 110? 110 minus 75 is 35. And that's the number of women we would need to add to the staff in order to reach that 20% of 550 objective. So that represents our correct answer, which is option E, as in echo. Now, again, I glossed over a lot of the math there. Again, let me know if you feel like it would be helpful to have the actual math done there. But more what I want to emphasize here is I didn't really make any equations, which is a totally legitimate approach to this question. And I didn't like back solve or plug in the answers or anything like that, which is also a totally legitimate approach. I'm just talking through an approach that, again, I think it doesn't get a lot of attention. And I'm not saying you need to master this approach to get a great quant score. You probably don't, but you might find it helpful. I certainly did when I first started exploring these kinds of just step-by-step approaches in the past. Interesting, it doesn't look like there's too many major pitfalls based on the wrong answer distribution data here, but of course, computation errors are and should be an ever-present worry for most of us. But again, as long as you don't mix up the math and you're generally comfortable with percent calculations, this one should go pretty well. I did mention those alternate approaches like equation or guessing and testing. I encourage you to try those out and compare them to the approach that we just talked through and just figure out which one's best for you. And the way to do that is just say like, okay, how could I make an equation here? And then you can web search the problem and see some examples of people making equations. Then you can sit there and say, okay, how would I plug in the answers and guess and test here? And then you can web search and see some examples of people doing that. Just validate your approach and your processes. And then take a step back and say, okay, what are the merits of each approach? What are the downsides of each approach? And which one do I think is the best approach for me? And there's a ton of value that comes from that kind of deep research on a problem. And if you're really striking out with alternate approaches, you certainly can ask a modern Gen AI tool to generate some alternate approaches. Can't guarantee you're going to get great results from that, partly just because of the state of the tech these days, but also partly because there aren't great alternate approaches to every single question. But for questions like this one, where there are a wide variety of approaches that could be beneficial, I recommend treating those kinds of questions as an opportunity to like work your skills in those different approaches rather than just like, let me get this problem right as fast as possible and move on to the next problem. Now, of course, that is the right mindset for test day. But when you're studying, usually you can afford to review and dig a little bit deeper on some of these math questions and you can get a lot of value from that. Now, sometimes you'll ask if there's an alternate approach or web search the question, see if there's an alternate approach, and there won't be. There'll just be really one viable approach. And that's fine. You can trust your judgment on that. I would say 99% of the time, most people are really, really good with that. But most people don't take the time to examine these alternatives, and I think that can greatly increase the efficiency of your study. Obviously, it's going to feel slower trying the same problem multiple times, but if you think about it, what's the better way to study? Like do 1,000 problems and learn 10 things, or do 10 problems and learn 1,000 things? Obviously, that's an extreme example, but I think most of you will find that even though it might feel slower to do that kind of deep review on questions, a lot of times it's a much, much, much more efficient path to your goal. That's my advice, and that's what I've found after working with, which I've honestly lost count of the number of people I've helped with this exam. But um, just give it a shot. If it's not for you, that's fine. But if you find value in it, I'd recommend using it when it works. I also mentioned if you're the kind of person who doesn't want to walk through multiple approaches for a problem and you're just aiming for, let's say, like a 645 or lower, then I think going with algebra on these questions is a really good bet. It's the least amount of material to memorize. It's probably the most familiar for the widest number of us because pretty much all of us have had to do algebra to get to this point in our lives. And at the same time, it gives you a good balance of safety and speed. It's not always going to be the fastest or the safest approach, but it's going to be the most familiar. And so if you're that type of person who's just looking for that, like, hey, just tell me how to do this thing so I can get on with my life, totally understand that. I would say just use the equation approach. Don't do the kind of approach I just talked through. Just figure out how can I set up an equation here, look that up, and use that. Now, the reason I mentioned that score threshold is I think when you're aiming for a score higher than 645, you're going to want to invest the time to practice those multiple approaches so that you're able to adapt to variants of familiar situations in the future. And that's often the way the hardest quant problems are constructed. The test writers will take like a familiar topic or pattern and they'll add a layer or they'll add a twist or they'll add many of both to make questions a bit more difficult to reason through. They're just more complicated, there's more steps. And in those types of higher level questions, you'll often start the problem one way and then later pivot to another approach or maybe combine multiple approaches in order to solve the thing. And that's totally normal on those higher level math questions. But I would say, again, like just if you're just aiming to get into the 600s or high 500s score for your targets, probably all the way up to the mid 600s. I think just having like a sort of like one line approach to certain type of questions is totally fine. Now, if you're not already naturally great at making those kinds of pivots, which some of you will be, some of you won't have to study very hard for this exam. It's definitely not the majority of us. It certainly wasn't me, just so you know. But some of you are in that boat, and that's awesome. And if you are, then you might already be naturally good at pivoting, and so you might not need to rehearse the whole multiple approaches thing that much. But if you're not great at that and you find it difficult to make those kinds of pivots, or you're often like trying an approach on a problem and like getting some traction and then just getting stuck, then I think that exploring multiple approaches on problems when it's possible to solve it multiple ways, even on lower difficulty level problems, can really help you develop that skill of being able to pivot and see multiple paths to the same goal. It worked super well for me. I used that to great effect in my prep. It's worked well for thousands of folks that I've helped through this process. And I believe it has a very, very high probability of working for you as well if you want to develop that skill. Again, not essential. Probably don't need that to get into business school, but if you're aiming for that super top score or you need to distinguish yourself because you're in a particularly competitive segment of applicants, then that's one way you can start to break out of that trap that a lot of people fall into with the quant section where it's just very, very, very difficult to score above 80 in the subscore. I think that 80 threshold, things get much, much more difficult. Every question counts a lot more above 80. And again, just to give you some hardcore numbers, I've mentioned this in the past, but to try to be as helpful as possible, like 78 is usually like more than good enough for any business school. Below 78, the argument in the quant score, the specific quant score I'm talking about, below 78, the argument can get a little bit harder inside the top 10. Outside the top 10 schools, it's probably fine. But 78 is kind of the minimum threshold that I've seen a lot of top schools prize. So 78, 79, 80, usually you can get up there without like really digging deep on multiple approaches. So I'm just speaking to you people who are like really trying to crack that 82, 84, 85 threshold. It's a very significant challenge for most people. but it is doable. And this is one of the tools you can use to help yourself get there faster, which is my goal for you. So if there are any notes to self to make on that problem, I'd recommend just pausing and making one right now or texting it or emailing it to yourself to log later if you're on the go. And in general, it's a good practice when you're studying. Try to distill down, like, okay, if I could only remember one thing from this question, what would I want that thing to be? And make sure that it's in a place where you're going to see it on a regular basis. Don't just log it and then never look at it again. That's not that helpful. Okay, feel free to pause if you want to do that, and then we'll jump right into exploring a problem that's just a little bit more complex. This is problem 136. The problem says a bar over a sequence of digits in a decimal indicates that the sequence repeats indefinitely. What is the value of 10 to the fourth power minus 10 to the second power, and that's in parentheses, so it's open parentheses, 10 to the fourth minus 10 to the second, close parentheses, times, in parentheses, 0.0012, and then the 1, 2 has the bar over the 1 and 2. So what that means is the 1, 2 is going to repeat forever to the right of the decimal. So it's going to, technically the number is 0.0012121212121212 forever. But the way they write it on the exam is just 0.0012, and then there's a bar over the 1, 2. So let me read that again because there's a lot to unpack there. The problem says a bar over a sequence of digits in a decimal indicates that the sequence repeats indefinitely. What is the value of the quantity in parentheses 10 to the fourth minus 10 to the second, that quantity, times 0.0012 with a bar over the 1, 2. So 0.0012121212 forever. Option A says 0. Option B says 0.12 with a bar over it, repeating forever. So 0.12, repeating forever. Option C says 1.2. Option D is 10. And option E is 12. So please pause. Feel free to think about how you would solve the question, actually do the math, and I'll jump in a moment. Okay, and I do want to be clear, like most of us are going to need a lot more time than like the several seconds I'm waiting here. I'm just waiting here to give you a chance to pause before I jump into the explanation. But yeah, most of us are going to need on more complicated problems, 2, maybe even 3 minutes in some cases. Some problems obviously will go faster, but I don't want the pace that I'm going at here to somehow make it seem like 10 seconds per question is normal. It's not at all. So this question is a bit more complex than the previous problem, like I said. Certainly not the hardest question by the numbers that we've gone through together in this series, but about 25% of us are missing this one, which is 2.5 times more than the previous question. So clearly there's a bit that's more challenging to this one, even though the question has like fewer words, fewer numbers. It's kind of interesting. The obvious additional challenge is that we're forced to deal with decimals. We're forced to deal with exponents. We're forced to deal with PEMDAS. None of that's present in the previous question where we could just do some fraction math and some subtraction. So if you want help upskilling with any of those areas, then we do have specific math basics episodes on each of those linked below. So if you want more skill with decimals, you want more skill with exponents, PEMDAS, all the basic skills, math basics involved in this problem, that's there for you. So I'm not going to dive deep on that stuff. Having said that, those fundamental skills are ridiculously important here because we have 12% of us, which is nearly half the total misses, going for option B, as in beta. And that's unfortunately not the right answer. There are a couple ways we might be getting to that answer, but it looks like the main way that that's happening is that folks are doing 10 to the fourth minus 10 to the second, and then they're looking at that and they're making it 10 squared. And that is not accurate. 10 to the fourth minus 10 squared is not 10 squared. So we'll dig deeper into like why that might be happening in a second. But if you did do that mistakenly, then you would get 100 times 0.0012 repeating forever. And that means you would shift the decimal place over to the right two places, and you would get 0.12121212 repeating forever, which would lead you to option B. Now, if that happened for you, better that it happens in practice than on a real exam. So if you're going to be wrong here. Having said that, we'd prefer to be right. So let's talk about why 10 to the fourth minus 10 squared is not 10 squared. Um, and there are quite a few reasons that we explore that in greater detail in the math basics episode. But the most important reason is it's not right, and it's going to cause you to get questions wrong if you do it that way. So maybe that's the only one that really matters. But the easiest way to think about this is just recognize that 10 to the fourth is 10,000 and 10 squared is 100. And if you subtract 100 from 10,000, you get 9,900, which is obviously not 10 squared. So that's probably the easiest way to prove that to yourself. Um, Having said that, it clearly remains super tempting for a lot of us that that we kind of like make up some exponent shortcut math there, and it just kind of seems like 10 to the fourth minus 10 squared should be 10 squared. So let's sort that out. A really good rule of thumb is that if you're adding or subtracting terms with exponents, you want to avoid using any kind of exponent rule shortcut. Just pretend when you see that adding or subtracting exponents, like, okay, none of the stuff that I think is going to work here, that's a shortcut, is going to work. Now, are there some things you can use once in a while? Yes. But it's so dangerous to try to think that way. As you can see here, 14% of us missing this question, I'd recommend just never doing it. So again, only use those rules. Like I'm talking about these shortcut exponents rules, such as multiplying by the same base means add the exponents, dividing by the same base means subtract the exponents, that kind of thing. Only use those when you're multiplying and dividing terms with exponents. And again, just if you are adding or subtracting terms with exponents, don't do it. Just avoid any kind of those shortcuts. Only use those shortcut rules when you're multiplying or dividing exponents. Just like burn that into your mind if that was an issue for you here. Even if it's not an issue, it's so tempting sometimes to do it. Just burn it into your mind anyway. And it's a super simple framework, but should save you quite a bit of grief. Um, so even though maybe in retrospect it seems obvious, like, oh yeah, 10,000 minus 100, obviously that's not 10 squared. Even though that might seem clear, it is a super, super, super common mistake. And if you fix it, you should be good to go. So that's kind of the main point there that I see is the big pitfall for a lot of us. And I think it's relatively easily fixed. So there we go there. Definitely reach out if you have questions. Let's talk about a correct solution and what that might look like. Um, I think one of the simplest is probably just distribute the 0.0012 repeating term into the parentheses. You don't have to do it that way. Like you can definitely factor out a 10 squared if you're more comfortable with that kind of math with exponents. But I think this distribution approach works great on this particular problem. So I'm going to talk through that one. But I'm not saying this is the only approach per our recent conversation. But if we just distribute that 0.0012 to the 10 to the fourth, that's going to move the decimal place 4 places to the right. And again, just check out the decimal episode on the Math Basics series if you're not clear how or why that works. And that would get us 12.12 repeating. So if we take 0.0012 repeating and we multiply it by 10,000, that would become 12.12121212 forever. Then if we distribute that 0.0012 repeating to the 10 squared as well, that's going to move the decimal point 2 places to the right. And that gets us 0.12121212 repeating. And so the result of that would be 12.12 repeating minus 0.12 repeating. And if we do that subtraction, that gets us 12. And that gets us to our right answer, which is E, as in echo. So again, might seem like that pitfall is just like too obvious to fall into. But again, by the numbers, like a lot of us are missing this question. Again, 25% of us overall with 12% of us, so almost half of us going for that answer B. So figured it'd be worth some discussion. Now, other pitfalls, sure, you might make a math mistake. Seems like the other half of folks, it's probably just that because there's a pretty even distribution between the other wrong answers. So it could just be like mixing up the numbers in your head or writing something down improperly. And we've talked about that just so much in this series because it's just such a huge deal on the math section. But yeah, again, it just looks like that biggest mistake is making the incorrect maneuver with the exponent rules. So just again, like remember that tip I was giving you before, adding or subtracting exponents, avoid the shortcuts. Only use shortcuts if you're multiplying or dividing terms with exponents, and that should really help prevent this kind of mistake for all of us. Um, there's certainly more that we could discuss regarding exponents, but I think we've covered a lot of edge cases in past episodes of this series, um, and in the math basics piece. So I think if you want more practice with exponents, pretty much every question involving them should be labeled as such in the feed. Like exponents will be in the title of the episode. So feel free to search the feed, and if you want to kind of go further with exponents specifically. In the meantime, let's keep the focus on that particular question simple. And as usual, if there's a note to self to make there, I would recommend pausing and making that note to self right now. And then let's wrap up with a question that, again, on the surface, it just it doesn't seem too crazy, but a surprising number of us missed this question, so I think it's worth some discussion. So the problem says, on a recent trip, Cindy drove her car 290 miles, 290, rounded to the nearest 10 miles, and used 12 gallons of gasoline, rounded to the nearest gallon. The actual number of miles per gallon that Cindy's car got in on this trip must have been between, and then you have the answers, which I'll get to in a second. So let me reread the problem first. On a recent trip, Cindy drove her car 290 miles, rounded to the nearest 10 miles, and used 12 gallons of gasoline, rounded to the nearest gallon. The actual number of miles per gallon that Cindy's car got on this trip must have been between A, 290 divided by 12.5 and 290 divided by 11.5. That's your range for the miles per gallon. Option B, 295 divided by 12 and 285 divided by 11.5. So again, the question is the miles per gallon that Cindy's car got on this trip must have been between 295 over 12 and 285 over 11.5. That's option B. Option C is 285 over 12 and 295 over 12. Option D is 285 over 12.5 and 295 over 11.5. And option E is 295 over 12.5 and 285 over 11.5. Again, recommend pausing and actually working through the problem on your own. And I'm just going to jump in so there's no like 3 minutes of dead air here. So this one's really, really interesting because arguably the math is even simpler than the first problem. And yet 30% of us are missing this one, which is just a giant multiple more people missing this than the first problem. So let's see if we can get this one turned around as well. The essential math behind this question is something we were exploring in our previous episode, actually, which is a rate times time equals distance equation. That's because at their heart, efficiency measures like this, like miles per gallon, they're just rates. For example, if your vehicle gets 30 miles per gallon of gas and you have 10 gallons of gas, how far can you go? Hopefully you're thinking 300 miles. That's just a rate times a quantity, but it's just gallons instead of units of time. Like instead of miles per hour, here we're miles per gallon. That's our rate. And then we're multiplying by gallons to get the miles, which in this case would be kind of like the work in a rate times time equals work question. Similarly, if you need to go 300 miles and you know your vehicle gets 30 miles per gallon of gas, can you solve for how many gallons of gas you would need? Sure. 30 times G equals 300. Same formula. If you divide, you would need 10 gallons of gas to get where you want to go. So that's kind of the core math behind this problem. It's just rate times time equals distance. And here the rate is a miles per gallon. So let's just apply that. Let's just apply that logic. So first she drove 290 miles and used 12 gallons of gas. So let's just compute her theoretical miles per gallon. I'm not saying you need to do this in the problem, just saying like for clarity's sake of what this problem is really asking us. That would be 290 divided by 12. We don't have to do the actual math here because you'll notice all the answers are in fraction form. So this is more of a conceptual question, but that basic relationship is still the key to the problem. And what's interesting is it looks like most of us figure that part out. But at that point, things can definitely go pretty wrong. For example, we've got 15% of us picking E as in echo. So let's think about how that might happen. The other mathematical concept here, besides rate times time equals distance, is this concept of rounding. And if you went for E, you were actually thinking about rounding in the right way. So it's kind of a tricky answer choice to unpack. So with E, the rounding is correct because if the question says the answer is between, which it does, if it says between 295 and something else, then on the exam, that means 295 is not included. If you see the GMAT use the word between 290 and 295, it means not 290 and not 295, only between those two extremes. Okay, and that's an important enough point to emphasize real quick. You'll just want to remember that if the GMAT says between, then by definition, it's not including the endpoints. Now, if it says inclusive at the end, now it is including the endpoints. So they'll always be very, very clear about that. Having said that, a lot of people see between and they believe it automatically includes the endpoints. So just wanted to kind of point that out here. I hope it helps. Now, go back to E. If you were thinking about that rounding piece, then you were probably thinking like, oh, 295 wouldn't necessarily round down to 290, but 294.99999 would round down to 290. So because 295 is not included because of the word between, because 295 is not included because of the word between, 295 is the proper upper limit for the answer there. Okay, so if she went something between 295 and whatever miles, then that means it would round down to 290. So 295 would be like the upper limit, the correct upper limit. The problem with E, though, is that even though 294.99999 is the maximum distance, 12.5 is the maximum number of miles, maximum number of gallons, excuse me, of gas that she used. 12.5 would round, it's technically 12.5 would not round down, but the answer 12.5 does round down here to 12 because it's the word between means 12.5 is not included, so it's 12.4999999. But the issue there with E is if we divide the maximum distance by the maximum gallons, that's a decent estimate of her miles per gallon, but it's not the lowest miles per gallon that she could have gotten. And it's not the highest miles per gallon either. It's actually in between those two extremes. And that's the key here because the minimum miles per gallon is going to be the minimum distance divided by the maximum gallons. That represents the bottom of the range of the miles per gallon she could have gotten. And that's because that's how fractions work. The smaller the numerator, the smaller the value of the fraction. The larger the denominator, the smaller the value of the fraction. So if we take the maximum distance and divide it by the maximum gallons, we're actually missing part of the full range there. And we instead need to do the minimum distance divided by the maximum gallons. And that represents the actual lowest miles per gallons that she could have had. And that's why 285 divided by 12.5 is in the right answer. That's the actual minimum is lowest numerator, highest denominator. So that's option D. Option D as in delta is going to be the correct answer here. So that's 285, which would round up to 290 or 285.001 if you want to think about it that way, since 285 is not included because of the word between. But 285 over 12.5, that's the bottom. And then the maximum is going to be maximum distance divided by minimum gallons. And that's going to create the maximum fraction, which miles per gallon is here. It's just the total miles over total gallons. So that's the max is 295, which again, we would round down, and then 11.5 in the denominator, which would round up to 12. So that's how we get the correct answer of D there. Now, again, if you have questions about any of this stuff, you have questions about the rounding or about the logic there, just feel free to touch base again at the GMAT strategy on current social channels, contact at the gmatstrategy.com if you prefer email. We're happy to hear from you. We'll do everything we can to help you out. But hopefully that's clear with the whole rounding thing and the whole between thing. I think those are valuable points. And again, 30% of us missing this question. So simple fix. You'll just want to memorize that to maximize a fraction, you want maximum numerator over minimum denominator. And to minimize a fraction, you want minimum numerator over maximum denominator. And that's the key to a question like this. And it's super, super important because so many of us are going for E. Which again is not right, even though it does show a pretty clear partial understanding of a lot of the key concepts here. So it's really painful getting like close to the answer and knowing what you needed to know, but just missing that one concept. So figured we'd try to decrease that pain for everyone. So again, just distilling that down, the true range of any fraction is minimum numerator over maximum denominator, and the maximum value of the fraction is maximum numerator over minimum denominator. That's a good way to distill down the main core of this question. So one final time, if there's any notes to self to make there for you, I recommend making them now. Feel free to pause and again, text yourself, email yourself. And just wanted to do some like maybe shorter but kind of punchier and more painful problems where I think just because the problem's simple, it makes it easy to like not take the question seriously. And I think sometimes that lack of vigilance itself can be a problem for us. And yeah, it's good to do these problems to just like remind ourselves that we want to remain vigilant on every GMAT quant question. Every quant question is an opportunity to either like get closer to your dreams if you execute well, or take yourself further away from your dreams if you execute poorly. And definitely don't think about it that way if you feel a lot of pressure already. But if you need to dial up the pressure a little bit and you feel like you're a little too relaxed when you're doing these questions, that's a good way to do that. I think we'll pause there. We'll be back soon with more strategies, more processes, more tips to help you make your dreams come true faster. That's our goal here. In the meantime, if you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies, everybody. Talk to you all soon.